Welcome to section 15.3, part 2. This is the 161st session of the CISSP exam prep series. This part continues our software testing tour with the techniques that stress code from the outside. In this session, we'll push software until it shows its weak spots. We'll answer several questions. How do you break code with bad input on purpose? Why must you test the seams between components? How do you probe for deliberate abuse? How do you measure how much you have tested? And how do you keep watching a website once it is live? Why does this matter beyond the exam? Because attackers rarely send the input you designed for. Picture a travel platform whose booking form works flawlessly for polite users, then buckles the moment someone pastes a garbled string into it. Testing for the ugly, unexpected case is what keeps that surprise out of production. On the job, your instinct to ask, what happens if I feed this the worst possible data, is exactly what separates robust software from fragile software. So how do you break code with bad input on purpose? With a technique called fuzz testing. Fuzzing floods an application with a torrent of invalid input, either random or deliberately crafted, to push it past its limits. As the software chokes on the garbage, the tester watches for crashes, memory overflows, or any other strange behavior. The goal is to surface flaws that normal, well-formed input would never reveal. Think of shaking a vending machine every possible way to see what makes it jam. Are all fuzzers the same? No. They split into two broad styles. Mutation fuzzing, sometimes called dumb fuzzing, takes real input from actual use and mangles it, flipping characters or tacking on extra data to create fresh garbage. That small tampering is known as bit flipping. Generational fuzzing, the intelligent kind, is smarter. It builds a model of the data the program expects and generates new inputs from that understanding. Just know the limits. Fuzzing rarely covers all the code and tends to catch only simpler flaws, so it is one tool among many. Why must you test the seams between components? Because complex software is stitched together from parts that must cooperate. Different teams build different modules and hand off through well-defined interfaces, so those handoffs are where things silently break. Interface testing checks each module against its interface specification, confirming they will actually work together. It is like inspecting the couplings between train cars, not just the cars themselves. A perfect module, joined by a faulty connection, still derails the whole train. Which interfaces actually need testing? 4 kinds. Application programming interfaces let code modules talk to each other and often reach the outside world, so you confirm they enforce every security rule. User interfaces let people interact with the software, so you verify they behave correctly. Network interfaces carry data between systems, so you test the connection's robustness, its encryption, its authentication, and its error handling. And physical interfaces, which touch machinery or the real world, demand extra care, because a failure there can have real consequences. Test every seam, not just the obvious ones. How do you probe for deliberate abuse? Through misuse case testing. Here you flip your perspective and think like someone trying to break the rules. First, you enumerate the known ways a user might abuse the application, like manipulating inputs to reach another person's account or drain an overdrawn balance. Then you actively attempt those abuses, by hand or with automated tools, to see if the software holds. It is the practice of playing the villain in your own story, so a real villain finds nothing new. Does abuse testing apply to artificial intelligence too? Very much so, with its own twist. A dangerous misuse of a language model is flooding it with overly complex or endlessly repeated prompts, deliberately draining its computing resources until it can no longer serve anyone. That resource exhaustion is a form of denial of service, and it counts as abuse, taking the model's normal function and weaponizing it. So misuse testing for these systems must probe rate limits, resource caps, and input length restrictions. You are checking that the model cannot be bled dry by a flood of demands. How do you measure how much you have actually tested? With a test coverage analysis, you estimate coverage as the number of use cases you tested divided by the total number of use cases expressed as a percentage. The catch is honesty. Nobody can truly enumerate every use case, so the number is inherently subjective. You can slice coverage several ways. Did every branch execute? Every condition, every function, Every loop, every single statement, treat the percentage as a rough compass, not a precise gauge, and always question how it was computed. How do you keep watching a website once it is live? With two complementary styles of monitoring, passive monitoring captures real traffic as it flows, giving you a true picture of what actual users experience, and a variant even reconstructs individual user journeys. Synthetic monitoring, by contrast, fires artificial transactions at the site, from a simple page request to a full scripted flow, to measure performance on demand. Passive only sees a problem after a real user hits it, while synthetic can catch trouble before anyone does. Pair them, and you both feel the present and probe the future. So let's bring it together. Fuzz testing hurls bad input to trigger hidden flaws in mutation and generational styles, though its coverage is limited. Interface testing checks the seams across application, user, network, and physical interfaces. Misuse case testing plays the villain, including draining an AI model as a denial of service. Test coverage analysis estimates how much you covered imperfectly. And website monitoring pairs passive and synthetic views to watch a live site. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.